Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, this is our lecture number 2 of unit number 9, Chords of a Circle. I'm your teacher, Rubina Khadim from Divisional Public School and Intermediate College, Lahore. We will revise few of our previous concepts about collinear and non-collinear points. As we know that the points which can be joined by a single straight line are called collinear points. Here in this figure, A, B, C and D are collinear points which can be joined by a single straight line, and non-collinear points. The points which cannot be joined by a single straight line are called non-collinear points. Here if you see in this figure 1, A, B, C and D lie on the same straight line, whereas the points A, B, C and D in figure number 2 cannot be joined by a single line, so these points are non-collinear points. Right bisector. What do we mean by a right bisector? A line segment, a perpendicular line which divides a line segment into two equal parts is called right bisector. Here AB is a line segment and PQ is a perpendicular line which divides the line segment AB into two equal parts passing through its midpoint M, and it is perpendicular to the line segment. And remember, each and every point which lie on the right bisector of line segment has equal distance from both ends A and B. The point P is at equal distance from A and B. Similarly, all the points which lie on this perpendicular line are all the points will be at equal distance from both endpoints A and B. Theorem number 1. Theorem number 1 states that one and only one circle can pass through three non-collinear points. If we have 3 points A, B and C which are non-collinear, one and only one circle can pass through 3 non-collinear points A, B and C. Given is that A, B and C are non-collinear points, one and only one circle can pass through 3 non-collinear points. We will write given A, B and C are 3 non-collinear points in a plane. We will write down the statement of the theorem, and the given is A, B, C are 3 non-collinear points in a plane. We will draw the figure. Here we have 3 non-collinear points A, B and C. We have to prove that. The second step is to prove one and only one circle can pass through 3 non-collinear points A, B and C, as we have discussed. The construction is, what we will do in the construction, that we will join point A with B, it's a line segment, and then B with C. We will join AB and then BC. We will draw the right bisector of AB, which is DF, as we have discussed earlier, that right bisector is a perpendicular line which divides a line segment into two equal parts. Each and every point on the right bisector of a line segment will be equidistant from A and B. So DF is the right bisector of AB. Similarly, we will draw the right bisector of the line segment BC, which is HK. In construction, we will write join A with B and B with C. We will draw the right bisector of this line segment AB, which is DF. DF is the perpendicular bisector of AB. Similarly, HK is the perpendicular bisector of the line segment BC. Remember, both right bisectors are not parallel at all, and they will intersect each other at point O. They will meet at point O. If we extend these both right bisectors DF and HK, we will have a common point where both the right bisectors will meet, that is point O. We will also join O with A, O with B, and O with C. We have drawn these distances by the broken line OA, OB, and OC. This is DF and HK are not parallel. These are the right bisectors of the line segment AB and BC. And both these right bisectors DF and HK will meet at point O. We will also join O with A, O with B, and O with C. As accordingly, we have proof of the theorem. In proof, we have two parts, statements and reasons. We will discuss the theorem in statements. A, B, and C are three non-collinear points. DF is the right bisector of the line segment AB. Each and every point on the right bisector of a line segment is at equal distance from both endpoints of the line segment. DF is the right bisector. Each and every point on the right bisector DF will have equal distance from both endpoints A and B. O is on the right bisector, so O is having equal distance from A and B. Every point on DF is equidistant from A and B. DF is the right bisector to the line segment AB. So O is having same distance from A as it is having from B. So measurement OA equal to measurement OB. Similarly, BC is the line segment. HK is the right bisector of the line segment BC. Similarly, we will say that each and every point on HK is at equal distance from B and C. BC is the line segment, so point O is having the same distance from B and C. We will write it particularly like this: measurement OB equal to measurement OC, as HK is the right bisector of BC. We have discussed in construction that HK is the bisector to the line segment BC, DF is the bisector to the line segment AB. O is a point where both the right bisector meet each other. So O is a point which is common on both the right bisectors DF and HK. O is having same distance from A, B, and C. These three non-collinear points, these three non-collinear points have equal distance from point O, which is common point to the both right bisectors DF and HK. Now it means O is the only point which is common on both right bisectors. O is having same distance from A, B, and C, yani OA equal to OB equal to OC using 1 and 2. So we will say that there is nothing any other point except O which is at equal distance from A, B, and C. So O is the only one and only one point which is equidistant from A, B and C. O is having same distance from three known collinear points. So OA is the radius of the circle, or you may say OB is the radius of the circle. And similarly, you may say OC is the radius of the circle, because O is a single point which is having equal distance from A, B and C. So we can say that it is a circle with center O and radius OA, which pass through all 3 points A, B and C. So we will discuss the theorem in this way. Prove with statements and reasons. Every point on the right bisector of AB, that is DF, every point on the right bisector of AB, that is right bisector is DF, on the right bisector of AB is having equal distance, O is having equal distance from A and B. Similarly, HK is the right bisector of BC. Each and every point on the right bisector is having equal distance from B and C. Both right bisectors meet at point O. So O is the common one point, only one point, which is common on both right bisectors. So OA is the radial segment. OB is also the radius of the circle. One and only one circle can pass through all these three non-collinear points A, B and C. So we will say that there is only one circle which can pass through these three non-collinear points A, B and C. This theorem we are having in our book on page number 181. Dear students, this is the view of page 181 from our textbook of theorem number 1. And you have to prepare and learn this theorem for the board examinations. Thank you.